And the last part in the simulation section is going to be the ropes. So let's jump over to our scene and let's just grab one of our pillars here, duplicate the setup here, and then we'll start to modify this to match our rope. So we're going to call this rope, and I think the corresponding rope to the pillar here, since I think the first rope that emerges is the would be the rope 2 corresponding to the pillar 3. So if we look inside here where we're grabbing the rope, I think we grabbing rope 2 corresponds to pillar 3. Just a bit of a naming thing there. So rope 02, and then let's jump inside here. Now let's start to strip out some of the stuff here. We have this water surface disturbance stuff. We definitely do not need this. So I think we can probably get rid of this entirely. So up to here and everything up to here. Get rid of that. Let's align these here. And we don't need our pillar. So we can get rid of this part here. And let's rewire our sim area transform to our rope selection, and then we can get rid of this. And now let's just move this a bit closer here just so we tidy things up. Here we're grabbing the rope, and then I think this is going to grab rope 1, yeah, because we're subtracting the digit of our subnet here. So let's just remove that. And then we should get the correct rope, rope 2. Perfect. Let's see, what else do we not need? I think the rest should be fine. Let's just quickly jump over and update our colliders. But before we do that, let's quickly cache our ropes. I don't really think we have to change anything here. Voxel size is fine. So let's just drop down a ROP cacher. And we'll call this one cache, and then collider rope. Hook that in there. Quickly grab our versions here, copy. Same thing that we've been doing over and over. Relative reference here. Grab our start frame just so that gets hooked up correctly. Paste relative reference. Could probably save that as a preset and then just use it that way, but it's too late now. It's probably one of the last caching nodes that we're going to be creating in this sim context. So let's go ahead, simulate this, and then make sure to update our collisions in here. So let's just jump to manual mode. So we don't need our pillar anymore, just the rope. That should be, oh yeah, and here, while we're at it, we can get rid of our advection, so the water surface disturbance, get rid of that. And if we go down to our whitewater simulation in here, this should, let me check here, the collisions should point to our rope. So this is going to be collider and then rope VDB. And next part is the smoke. So in here we have our pillar, and let's just change this to our rope. Capital. There we go. And I think in this mist simulation we don't have any collider set up. All right, perfect. So let's go ahead and quickly cache this. All right, and as we can see, all working fine. Who would have expected that to work? And then, so that's good here. Let's check our color fading here. So we're grabbing our pillar. We should change that to our rope. Let's update that in there. So we can get rid of our blast here since this is referring to the pillar. This should be hooked up to our start frame. Perfect. Let's see if we're getting some points scattered here. Check the amount, that should be fine. Getting the up. And yeah, we can probably get rid of this loop here since we don't really need this. The only thing that we do need is the point deform. So let's just get rid of these two blasts and also the for each. And then this should work as expected. So basically have our rope deforming here. Perfect. Then I think this all can stay the same. Grid is still hooked up. That's fine. We'll just have to change our tank area. So basically where we're going to be simulating, just to update that. But for now, this should be fine. Maybe just one thing, if we have a look at this, for example, since we're only going to be simulating like a small strip of our rope, I would go ahead and probably expand this. So let's just drop down a transform here and make this a bit bigger. So first we want to center our pivot. So CX, the old school expression, $CEY and $CEZ. And now if we scale this, this should scale in the center here. So let's just set this to 2, just double it. And then that should get our points for us. Perfect. And then the color transfer that will happen when the rope drives through this, and then we're going to have our regular color fade. So next, let's set up our flat tank. So first we got to select our burst frame, so the frame where we want to have our center on. And one thing that we see here is the rope is in a strange angle, so it's not parallel to the grid, and that's something that we want to change. So we want to add in a transform, and then after the simulation transform it back. So let's drop down a transform, and then we'll call this change transformation, and then we'll color this bright yellow, just so we know we have to change this. And then let's rotate this until we get this kind of straight, something like that. That should be fine. And then let's grab our burst frame here. So in this case, it's let's see if we go any higher, if this will change anything. In the end, it does kind of swing over. So we want to, let's just set this to 70 or something, just so we have a slight angle already. And then we'll see if we update our flat tank here. And then we're also going to make this a bit bigger. So let's go a bit smaller in the X size, and then way larger in our Z size, maybe a bit more. Yeah, and that should be okay, because the rest of it is going to be definitely touching with, so here is our pillar, and so this is already intersecting with our pillar simulation, and this is definitely intersecting with our ship simulation, since this is the end of the rope and that's where the ship is attached. And so we just want to fill the gaps kind of in between those two, and so we don't have to make this much bigger. And this is the reason also why we're rotating it, so we can simulate in this area to have it basically like a straight line, and then later just rotate it back. Otherwise we would have to create like this huge square shape, and it would just be a big waste of simulation time. And just to have a look here, if we have a look at our animation, just to see, because we just want to get the area where it's touching. So let's see, it's still inside, and then it lifts off. Yeah, and then that would be perfect. You just want to try to avoid not having it going out of the side, although that probably wouldn't matter as well. All right, that seems fine for our simulation area. Don't really have to set up anything else. The resolution, I think we're going to keep it as is. Let's just quickly jump inside and double check this. 102. I think we'll just give it a go with this, since we're probably not going to be using the flip anyway, just using it for the whitewater simulation and just going to be rendering that on top of our regular ocean. So let's just keep this. I think that should be fine. Let's just double check our color fading here, that this is working. Now that we have the correct grid, and as we can see, this is getting a color. Let's just go ahead and simulate this here. All right, seems to be working. Who would have expected that? But what we're going to be doing for our whitewater simulation, we're going to be extending the container and basically have whitewater living outside, or maybe just for the mist, we'll see. So this is our color ramp, so basically a fade off. So as soon as this dives through the water, it's going to get the color, and then it's slowly going to fade off the longer it lives in the air. When this is probably going to be the main whitewater source, just to have like some spray mist stuff coming off of this, so we can distinguish it in our render later on when we have the ship and the pillars and we get a connection between those two. Since otherwise the rope, since it's very, very thin, it's probably not going to be visible at all if we don't add any additional effect to it. All right, so let's go ahead, and I think we can start and run our flip simulation here, and then we'll take a look at this once this is done. So I'm probably going to send this to deadline so I can do something else while in the meantime. So submit to deadline. All right. Definitely probably a bit of overkill, but it looks nice. So we got our rope moving through the water, which is not really creating any interesting motion, as I've probably would have assumed anyways. So we would have to go a bit higher res if we actually wanted like water to get pulled up and drip off the rope, but this is definitely overkill. We just want to get the information from this for our whitewater simulation. And this, since this is almost flat, this can definitely lie on top of the regular lake or the other simulation that we have from the ship and the pillar surface area. So, all right, continue from here to the whitewater. So nothing much we have to change here. We have our rope emission, and let's just check this out, see how this looks. And we might have to boost the emission of the rope, of the extra emission that we're adding here, just to, wow. Well, of course, the wireframe, you're not going to see much, just to emphasize on that. So I think I'm just going to maybe just double this here, go to 10. Yeah, so we do get a bit more at the top here, and a bit more emission while it's running through. And then here, I'm not really going to change anything there. Let's just quickly check this part here. So this is mainly the bottom one. So let's just rasterize this and see how this looks. Seems fine to me. So I guess let's just cache it. It's going to be a quick run through. I hope so. Probably until we run into some issues, but so let's cache this. See maybe if I can. Let's send it to the farm. All right, done caching that. And here we have our fluid surface as well, since we're splitting that, and to use that in our whitewater simulation to distinguish what is on top of the fluid and what is inside. And here, let's just quickly check the multiplication of our additional density. If you remember from the previous sections, I think that should be fine. So here, the combination of those two. And here, let's just change this to our rope, because we do want to add the velocity of our rope. So if you remember here, we were just adding the velocity to the rope sections, because obviously there's no flip living on top there, but we do want to have the velocity from this get carried on to our emission, since we are emitting from there. And in the whitewater solver, it is grabbing the velocity from that area, or basically from the whitewater volumes. That's where it's getting the velocity to put onto those emission points. And so that's why we want to merge that in here. So make sure this works correct. Perfect. Then whitewater simulation, we already changed the collision. Let me think if we should change anything else. Yeah, the bounds. So here, let's just go ahead and multiply this by 3. So we're just really extending it on all sides so we can have whitewater going outside. Now, since it's going outside, we're going to have an issue once the stuff falls through the surface. So there's a quick fix, or a quick thing that we can do, is we can basically check against the height. So if it goes below, for example, our water level, which would be 0, and it is not inside the surface. So basically, if it's not inside this surface here, since then it would be bubbles that are rising. Since the rope is moving through there, so we do not want to delete them. But if it's basically underneath a certain Y value, so basically our water level, and it is not inside this surface, then get rid of it. And the way we can do this, just quickly drop down a geometry wrangle, and let's just disable our simulation here. So if our current Y position is smaller than our threshold, so let's call this, I don't know, our minimum, then let's just define our sampling. So sample SDF, and that is equals to our volume sample of the second input, which we're going to provide in a moment. And then the field is called surface. Oops. And then we're sampling at the current point position. Getting into a lot of typos here again. And then if that sample SDF is greater than 0.1, then remove the point. Remove point from the current input and the current point number it's iterating over. So I hope this somehow makes sense. So let's just quickly change this to myself. First input, second input is going to be sup, and then we're going to point it to our source here. So let's just grab that and paste relative reference. And this is where we're going to get our surface field from, which we're referring here. And then we're just checking. So basically, if it's outside, since everything that is inside is negative, everything that is positive is outside, and we're just adding a bit of padding there, just to be sure. And then let's create our interface here, and I think we'll just leave it at 0. So we probably could have just compared it against 0, but just in case you want to change that, you can do that here. So basically, first check if you're below 0. If so, then do the volume sample, and then remove the point if you're outside of that volume. So basically what we just said, and I will just call this kill below outside. Let's just color this. And that should be it for the whitewater part, I guess. Nothing much to change here since we already have a solid setup working. So I guess let's go ahead and simulate this. So render submit to deadline, and this always takes a while. Okay, and here we should have, let me just check, there we go. Oops, put it into a good angle here. Here we have our whitewater simulation. Very beautiful. So got our rope pulling up, and then we're having the foam which is getting created. And here you can see the reason why we extended that simulation area outside, because otherwise everything would get chopped off here. But since the rope is moving around above the water, we still want to have that in the simulation here. And so, I mean, it carries on until here, and then we're just left off with the whitewater still on the surface. And now something that we do have to change here is create a fall off around the edges here, so we don't get these hard, sharp borders. And the other thing is that you might have noticed in the beginning, there's some substepping going on, and we're just gonna do a super cheap trick to fake or fix that. We could go about changing this in sim and trying to get it to work there. Definitely, if you have the time or want to, go ahead and do that. But since this is just like a small secondary effect, we're not really going to bother about this. And so the way we're going to go about this is just by stretching this along its own velocity randomly. All right, so let's just drop down our angle. And I'm not sure, but I think we've already, I think we've created this before. Stretch along velocity. I think it was somewhere down here. Yeah, stretch along velocity. Cool. Just to be sure I'm not doing something that we didn't cover. Want to avoid that. And so what we're going to do is we're just going to change this manually to something really high. So something, I don't know, probably have to go, I wonder. And I think because if we look at this, it's also stretching things that are below, and we just want to fix the stuff that is visible in the air. And we don't really care too much about the stuff down here, and we definitely do not want to stretch our foam later on. So let's just quickly add a height gradient in here. So this will be our height gradient, which is equals to, let's fit our y position, so v at p dot y, and then our min height, and then max height 0, 1. And then close that, and then we'll just multiply this times our height gradient. And then let's promote our parameters, and then we'll go to 0.5. So everything that reaches 0.5 gets the full stretch, and everything that is below does not. So negative 0.3, 4, probably going to go even higher, 0.5, something like that. And I think because if we turn this off, this is only apparent in the beginning, and then at some point it looks normal, so it's moving at a good speed. And here we don't want to stretch it, because here we're starting to get our clumping, as you can see here, and things are starting to form and create nice shapes and stuff, and the overall look is quite cool. I like it. We get like this stringy stuff here. So we want to just go ahead and quickly animate this. So here, the min, just alt click, and then start setting keyframes where you turn it on and off. I'm just going to do this on the side now, and then we'll come back once I've finished that. All right, so I've gone ahead and animated this. So when we come up, we do have a high band, high stretching, and then we're going down to 0. And then towards the end, we have a bigger move again, and then we start to stretch it again, because otherwise, if we turn this off, you can already see the banding there. I mean, it's not much, but it does help get rid of that overall feel. And since this is something very subtle, we don't really care about being very accurate about this. All right, so done that. Maybe in the end we could probably go a bit higher, but probably already inside the ship anyway. And from here you don't really see it. So keep that as is. And so now one thing that we want to adjust here is we can see this is flat all the time, obviously. And so we're going to go ahead in the meshing part here. We will be modifying the position of our flip, and then afterwards also modify the position based off of this here. And because when we have our ship rising, we have these big waves coming in, and we want this to just carry along on top of that surface. I mean, in compositing, we're probably going to start to blend this out at some point, but still the first initial movement or the first waves that will pass over this, and we want this to follow along. And so the way we're going to do it, we're going to change the position of our mesh, and then we're going to use this mesh to project our whitewater on top of it, and then have that displaced as well. So let's start here with our meshing. And so let's go ahead and just right before the splitting, let's just stop the calculation there. Drag this, I don't know, a bit down, make some room here. And then what we want to do is we want to grab our transform here, and we're going to hold down Control, Shift, and Alt and drag it just to make a reference copy here. And then we're going to hold down Control and Shift and left mouse click on, where is it? Invert transform. And then we can tick that. And so basically what this does, if we hook this up here and have a look, might be better to do it after our deletion here to see that better. So first we have it in the center. Obviously before the position is this here. I mean, this is the position, the original position. There you go. So original position, then the transformed position. Or we can just turn this off like this. And then we want to get back to that position, which is this one here. So if we compare with the original, it's the same. And so this is the transform that we want to use to put them back in place. And so this is what we're going to do here after the meshing. So we're going to mesh it, and then we're going to transform this back into position. So let's just quickly let this calculate and then continue from there. All right. Done generating the surface. It's so beautiful. So to mesh the transform of the bigger part, we have to grab our flip sim from the ship. So we'll do that here, drop down a object merge, and then we'll jump to our flip simulation. So that would be up 2 levels, and then I think it's called sim and then ship. And then that would be, I think it's render, and then water. And then we have the same for water with no displacement, since we also split that up, and then we just merge those two together, select them, drag them together, and now we have our first, of course, unpack. So let's drop that down here, and now we have our cached ship simulation. And then here you can already see this wave stuff, and that's what we want to carry along. And if we, let's go a bit further. So I hope you cached this. I did before, and so that's why we can use this. And it loads quite quick, I think. That's nice. So let's just quickly check where this is living. Oh, nice, it's calculating again. All right, see you in a bit. All right, and now we can see where this is living. So this is going, like, this is almost just inside of the entire flip sim. And as you can see, it's not really matching that good, although it is not that too bad because we've done our flattening here and the waves haven't carried out there yet. So what we'll do here quickly is grab, so basically I don't think we have to split this, so let's just get rid of all of this here and this here and just have our cache there, and let's just quickly cache this frame. So save to disk, and now unpack probably. Unpack. There we go. So cool. So let's just take this here, and I'm just gonna drag this up top here. And so what we want to do is quickly store our rest position. So just drop down a rest position. So that's just the current position. And then, so what we're going to do, we're going to take this, move it up, just some arbitrary value, and then we're going to ray it back down onto the surface. And the reason why we're moving it up, because this could be underneath. And so we always want to be above the water and then ray it down. And then everything that gets rayed down, we're going to compare that. Basically, if there's anything left up in the air, and everything that is left up in the air gets its original rest position back. So that's where we're storing that here. And everything else gets a new position here, plus an offset that we grabbed from the rest position .y minus the new y position. And so we add back these ripple stuff here. So I'll show you that how this looks in a moment. So let's just grab a ray and push this up. So v at p is equals to p dot y, of course, is equals to 100. And then we will just ray this these points here onto this surface here. And so now we'll change the direction to a vector, and let's just delete this here. And then set this to 1, rather -1, because we're in the top. And now you can see we're raying everything down onto the surface, and then most of it gets rayed onto the surface, but some stuff that is outside still stays up here at value 100. And so what we want to do now is basically compare this or check this. And so drop down a wrangle here. So if position y is equals to 100, our position is equals to our rest position. And so now this gets back to its original position here. And what we want to do now is set or add our difference. So vector at position dot y plus equals our v at rest dot y. And now, as you can see here, we're getting our ripples back. And just to, let me see if we can just do a soft transform here, just to show how this works. Quick selection here. And then translate 0.3. Oh yeah, of course, gotta hook this up. And then now you can see basically, if we don't do this, I mean, it is right onto the surface, but we still want to add that difference that we have here. So we get back our ripples, but we still have this new position of the underlying water surface. So obviously we don't want that. And now the only thing, or the issue that we have is here on the outside, we are adding our y difference. So basically we're getting a doubling in this. So if we would let's just duplicate this node here. And let me see. So let's get rid of this. And here, let's just get rid of this. And now, so if you look close to the borders, where we already have our displacement, because we switched it to the rest position if it was not right onto the surface. So that's why we have these bumpy areas here. And then if we add in back our difference, we're just doubling it, and that's something that we do not want to do. So the way we can do this is if we just check if we are at the top, and if we are at the top, or if you were at the top, then we just we don't want to use this. So that would be int upper, for example. Our upper position is equals to the v position dot y, so vector at position dot y is not equals to 100. Then this will evaluate to true, so basically to 1. And if it is 100, then it will be 0, so not true. And then we can just multiply this by upper. So this is going to be either 1 or 0. And then now we should basically get rid of the doubling effect on the border. And so we'll call this back to rest and y, add y, better, and add y. Nice. And then we can feed this into our caching here. So we can get, let's just jump to manual mode before it starts to cook again here. Hook that up in there, and then this into here, and then this goes into here, like so. Let's just tidy this up real quick. So select these here, hold down Shift A, drag on the top, and then we straighten them. And then let's drag these over here. Don't need that anymore, don't need that. And then we can go ahead and cache our mesh here, and then we will continue with our whitewater part, where we basically we match that same surface or that same banding to our whitewater. And that we will do that where is it? Whitewater, so right here. Let's just quickly name this stretch along v fix substeps, and then we'll do this here, and then afterwards we'll be caching this for rendering anyway. And so here we're just going to probably do kind of the similar technique where we're going to be raying it onto this newly created grid here that we have, and then we will do the same with the Y difference and stuff like that to match it there. All right, continuing where we left off last time. What we want to do now is ray also our whitewater to the surface, so it matches up with what we did up here. It's basically where we changed the surface to match the overall movement of the big waves from our ship simulation. So let's just give us a bit of room here. So let's select all these nodes up until our stretch velocity substep fix thing. Just make a bit of room here. And so what we'll do is we'll just grab this same setup that we have up here. So where we store our rest position and then do the raying and then back. So let's just copy, I think it'd be this part here, copy that and paste it down here. And let's connect these up there. And now let's grab our surface that we created here. So we're just going to merge in our water surface And now one thing that we'd have to do is we have to rotate this back to our position. So let's just grab here our transform, duplicate that, drag it down here, connect it. And first let's do unpack. And then that should be fine. We should be back at our position here. And if we have a look here, that's also where our whitewater is living. So just so we have the same position there. And then let's change this ray geometry to that one. And now we should get our points right onto the surface here. Probably have some flying up in the air, the ones that didn't get moved down. And then we fix that again with our back to rest and adding our Y position. So now if we have a look here, it's more closely matching the surface. So if we check here, oops, this one here, or rather the rest position, because otherwise it's this is the Y transform. So Y transform. And now if we look at it from here compared to this one here, we now see it's sunk down a little bit, probably because the ship water surface is going down in this area. And now let's just compare. Let's see if we can find a frame where we have some mist in the air, and let's just compare this to the previous one here. And there we can see that it's not really changing the stuff out here, but rather only the surface that it's trying to match. Now, one thing that we do notice here, I mean, maybe not in this, let's see if we can find a better frame, but probably then all the whitewater is already gone. So let's try compare it to this one here. No, I don't really see it there. I mean, we do see, like, for example, here, this dip. So basically where it's going down. And that's also part of the effect that we're doing here. But if we look at the beginning, I think maybe here we can see it. So let's just compare these two. And there you can see it's deforming everything. And that's because it's raying everything onto the geometry, and then it's adding back that Y position. So everything is getting that offset. And so what we want to do is just take this as our position for the bottom part. So we'll just create a new, you probably guessed it, a new wrangle. Hook this up to our original, and then the second input to the transformed one. And then here we're just going to blend, to the rest position here. And then we're just going to blend between those. So just call this our mix position. And then in here, I'm going to create another height gradient or height multiplier, whatever. So float height mix, just call it mix, and then fit our Y position. So vector at position.y between our minimum value and then the maximum value that we want to be using, and we're going to invert this. So basically it's going to be 1, so mix to the previous position, and then 0 once we reach the maximum height, keep the original position. And we'll show that in a minute here. Did we close all this correctly? Perfect. And now let's just grab our previous position. So vector previous position is equals to, and then we're just gonna get our the point position from the second input. So second input, which is input 1, since the first input is input 0, obviously, and then at point number, the current point number is running over, and since the point numbers is the same, just deformed, we can just use point number here. Otherwise we would have to base this off of the ID. And now we just set the new position to a mix between those two. So between our current position, so vector at our current position, and then our previous position, and then the mix will be our height mix. And now if if we create this, so minimum 0.5, that's where we want to have the full effect, and then it's going to slowly fade in to, I don't know, 10 centimeters above. And so let's see, we're now just deforming the bottom part. Because otherwise, if we would be deforming the top part. So if we, let me see, if we go back here, we're also deforming the top part, and then it's not going to match with our rope anymore. So we just want to avoid that, especially when there's like big waves coming in. This is going to also carry on to the top, and then we're going to have waves also on the top. But we just want this for our surface, and that's why we're just mixing between our original position, which is the stuff that we keep on the top, and then our newly deformed whitewater, which is matching the surface. And then we can hook this up here to our P-scale. Let's just order this correctly here. Move this over. Let's see if we can get a nicer layout here. Always good to hold down 8 so we don't snap onto that node, and then move this to the side here. Hold down A on the bottom node, drag down, and then we just align those nodes there. Super handy, really useful tool there. Let's just move this to the top. Get our rest position here, and then we can probably move this up, but let's first, I think the next part that we will be doing is after all of this here, we will, let's just move this up here. So what we're going to be doing here, we already spoke about this, is basically we have stuff falling off the surface at edges here, and also we get some like borders, so to say, here, especially if we go to the end. We get like this. If you look at it, you really can see the container here, and that's we just want to fade that off. And so the way we'll do that is we'll just create a surface, basically a plane that is matching the bounding box of our simulation, and then we're just going to take that, extrude that down, and so we get a border around it, and then we're just going to smooth it so we get round borders, and then we're going to use this to create a fall off from there inwards, and then just scale down the P-scale. And so points that live on the edge here are just going to get scaled down and not be visible, and then the further in it gets, the more they're going to be visible, and that way we get like a nice soft transition and don't get these weird edges here or these corners. So to do that, let's just drop down a grid, hook this up to our flat tank. So let's select our flat tank here, wait for this to finish calculating the size, copy, go down here, paste relative reference, and then we want the position, speaking of the center here, and then paste relative reference, and now we should have a grid that is matching. The only thing that we do want to get rid of is our Y, and just set that to 0 again. And now we have our simulation area. The only thing that I'm wondering is why it's not matching up here. Yeah, of course. So what you can see here, we have X, Y, and Z, and on the plane we don't have the Y position. So this was copied falsely, so this is going to be our Z. And now I think we should have a matching grid. Perfect. So here we have our grid, and let's just reduce the rows and columns to 2 by 2, so we just get a rectangular shape here. And then let's extrude this down. So poly extrude, select that here, and then transform local world, and then let's go -5, and now we get this kind of bath tube shape. And then we'll take this and subdivide it just to get smoother edges. Obviously this is too strong, so let's just change this to 3. And then we can go ahead and overwrite the crease weight. And let's just up this to maybe not that strong, but something like this should be fine. So it gives us like a nice round shape here, so we don't get rid of those hard borders. And then let's just compute the normals. Hook that up here, change this to points. Let's just quickly check our normals here. Should be fine, facing inwards, but maybe we can just reverse them because we're going to be using these later. And now let's just scatter some points on the surface. Let's change this to not force turtle count, but rather density, since for our other rope simulations, this container is probably going to be put a bit bigger or smaller. And we want to have a consistent amount of points, so consistent density. Just turn off the relax here, and let's go up a bit higher, 30, 40. And now let's drop down another angle. And now we're going to offset these points outwards. So basically, if we have something that is living outwards, it definitely is going to get covered. And so what we're going to be using here is our stretch along velocity. And we're just going to modify this to not use velocity, but use the normal. And then let's break the connection here. And then set this to, I don't know, a high value. 3 looks good to me. And now if we look, we basically have this hollow inside, and then our points that get extruded outwards. And this, we can now use this to create our fall off. So let's create another angle, or I said let's do some VOPs, so let's do a attribute VOP just to have this in here as well. So connect this up, and now we're going to do a point cloud lookup. So PC open, hook up the second input, which is our points that we just created, and then the position we want to sample from is our current point position, which is our whitewater. And then let's do a filter to grab that new position, and then we'll just kind of calculate distance between that newly sampled point and our current point. And then that way we can see if it's close or not to those points that we just created before. And so this is the distance, and we want to fit that distance to the maximum radius. So promote parameter here, grab our radius, and this is going to be our max distance. So we're going from 0 to our max distance, and in this case we probably want to promote our min distance so that we have, or so that we ensure that we have a certain amount of points that are definitely included. And so we'll leave this at 0 and then maybe change it later. So we'll call this min distance, and then here this is our radius. And let's go really high on this one so we can get a nice fall off there. And then we will run this through a ramp. So ramp parameter, change this to spline, and then we can redistribute this. So let's just quickly hook this up to our color so we can actually see how this looks. Right now it's black because we have to reset our ramp, and now we should get a fall off here towards the edges. And so let's go for a min distance. Let's go a bit higher here. So maybe 0.2 or something, and then let's go for a bigger fall off, radius of 2, and let's remap this here, spline, go a bit lower, just so we really get rid of those edge parts, maybe up a bit in the core area, and this does look good. So if we turn this off, full effect, and then we get basically this fall off around the edges, and then we get rid of that, of those hard edges, borders. I mean, you could get around this with using a bigger surface so that it doesn't really start to fall off and it just lives naturally. that would probably be the best way. But since this is just a subtle effect that we're hardly going to see, this won't really matter that much, and so we're just going to do it this way. So now that we have that, one thing that we do want to make sure is that, for example, if we go further, we have the points in the air. We do not want this weird mask going up here and have these points scaled down as well. So we have to exclude them. And so the way we're going to do this is just by height, as we did also for the raying part. And so what we're going to do here, this is basically our height fit in VOPs. So we're going to do a vector to float, hook up our position here, and then we'll run this through a ramp. But before, we have to fit this to 0 and 1. So let's hook this up, grab our Y position, hook this up into our value, and then we'll promote our, this is going to be min position, and then promote parameter, and this is going to be our max position. And then we'll connect this to our ramp, and just got to give the ramp another name here. So we'll call this ramp position, or let's just keep it the same. So we just have the same distribution, because I think that's probably the same distribution that we want to use anyway. And then we'll just grab the maximum of those two. Let's just combine them. Well, first, let's just check our ramp here, make sure this gives us what we want. And so now we have everything that lives above a certain value. So first we got to set this up, of course. So start at 0 and go up to 0.1 or something. And now we can see everything that is in the air is white. And then if we combine this with our mask in the middle, we just grab the maximum value of those two, and then whatever is white stays white, and whatever is black will stay black if it's not, if it doesn't have a value that is higher. So what we had before here in this area, so if we disable that, we see it was going up here, and now since the white values of this ramp here, or of this mask that we created, is higher than the blacks there, it's just gonna keep that due to the maximum here. And now what we want to do is use this as a p-scale multiplier. So we'll bind our p-scale and then multiply that by this value. So basically everything that is 1 stays the same, and then everything that is black gets multiplied by 0, and so it will not be visible in the rendering. So I'm just going to grab our particle scale, drop down a multiplier, connect this here, and then to our mask that we created, and then let's export this again. So bind export, and then this will be particle scale. All right, let's go up a level. Let's call this our mod p-scale edges or borders. And then we can copy this node over here and hook that up there. So we have the same for our bubbles that go towards the edges. All right. This concludes the rendering part here for the whitewater. Next is our mist. Let's quickly go over this here. So here we have our scattering based off of the density, and it's clamping the Y, so we only get emission from the top because that's where we want to be emitting the smoke from. We don't want to have constantly smoke being emitted from the bottom part. And then we'll delete based on the speed. And so maybe if we lower this just half it, not really gonna change much. Okay, so let's just keep it the same. as it was. Rasterizing, let's quickly check this. Looks fine to me. Same for this, just combining it with the bottom part and getting rid of the slow moving parts here. So if we disable that, you can see we have the density and the bottom. So just disable the grid so we can really see that. And then based on the speed, since this is not moving really fast, it already automatically gets rid of that. So only if there's high velocity white water down there moving, then it will emit some smoke, and that should be fine for this purpose here. So just go ahead and cache this. Select this, save to disk, and there we go. It should be. So now we have our smoke source, and then we can jump inside our smoke sim, mist sim. Make sure our colliders are set up correctly. So this is our rope. Let's just rename that. I think we already changed this here. Then we have our water surface. That should all be fine. Just go to the very beginning. Let's see if we can play this. All right, let's stop our simulation here for a moment and have a look at what we're getting. Perfect. So just some stuff falling down, some mist, basically from the rope. I think I'm just going to go ahead and cache this and see what results we get from this. So let's go up a level again, and then here, whitewater smoke. I think we might have to extend. Let's just keep it as is. That should be fine. Should cover the range here. Let's just go ahead and simulate this, and then we'll see what we get out of that. So I had this. I'm probably going to submit this to deadline. Oh yeah, before we send this to the farm, first what we want to do, looking really nice here. Sorry. What we want to do is transform this back to the original position. So let's just quickly grab that transform node. I think that would be this one here. Yep, so the invert. Let's drop this down where we're here. So drop that in there. And now we should be back at our original position. Let's just quickly compare this with our incoming ropes. Yep, perfect. And that matches up. All right. Now let's cache it. So submit to deadline. All right, let's just have a look at our simulation here. Nice. Perfect. Does exactly what we want. Getting some really nice detail in there, especially here, this when it starts to come towards the end here, all these nice effect here, looking like water, and then basically just dragging down a bit. So like really subtle mist stuff moving around. Let's just quickly play this through this again. Nice, like it. Perfect. So let's cancel this. And I think we can probably just go ahead and cache our mist simulation. The only thing that we have to do here is go back before we use this for the advection, just transform it back. So let's grab our transform here, create a reference copy there by holding down Control Shift Alt and dragging, and then we will drop this down here right after. And then this gets transformed back into the straight line here. And then we can use this for our mist advection. And then after the mist advection, we're going to transform this back. So let's grab this here and then put it back to word space and then cache it. Although we are changing this afterwards, so I can probably do this after the simulation. Since if we cache this again, we'll do it there. So let's just drop it right before the rendering. And then we definitely need to add this to our whitewater rendering. Maybe you've noticed that already and already did that. If not, just in case, just take that, drop it in here, and drag to the other side and there. So we definitely get our correct positioning there. So we have it on our surface, if I'm correct. Yep. And we have it on our whitewater we have it on our smoke, and we have it on our mist particles. Perfect. All right, let's go ahead, send this to the farm. Where is it? Here's submit to deadline. And here we have our mist simulation. Perfect. Just some particles floating through the air. They're probably going to fade off anyway. So let's just turn this on here, our H fade. Yeah, and probably not really going to be visible for that long, and then fade off already. Cool. All right. I think this wraps it up for the, I was just going to say pillars, but this is the rope. So the thing that we're going to do now is just go ahead, update the SimNet corresponding to the cachers that we have set here, and so that we get rid of the parts that we don't need, and definitely add in our collider here, and then we can go ahead and duplicate the setup, and this should take the correct naming here. And then the thing that we have to change manually is here, the impact frame, and also the transformation that we want to change, so that gets transformed correctly. Luckily, we created the reference here, so it all updates automatically whatever we change this here, so we get the correct positioning there. And then I think other than that, probably also the start frame, which I would set to the same as we have here in our pillar simulation. So just make that the same there, and then just create 3 of these, send that to the farm or sim it locally, whatever method you're using. And what I'm going to do, I'm just going to quickly go over this. And then the thing that we have to change here as well per instance is, meaning per rope, is the animation of the whitewater stretching, so that post simulation fix that we did here to fix the banding. This is going to be different for each of them, and so just quickly go through after the simulation and just check which frames do I have to stretch, and then which frames I don't have to stretch, and then just so you don't get a strange banding behavior there. And then we can run through that setup. I'll go ahead and do this quickly, and then we'll come back and just quickly go over the settings that I applied, so I don't have to let you through this watching me changing the parameters and stuff like that. Probably got better things to do. All right, let's just going to go ahead, update the SimNet, and then apply this to the others. All right, I just quickly went over, simulated all these, and basically made some adjustments here. So we can just quickly run over what I did here. Basically, for the first one, the sim start frame is the same, since it's quite close to the third one that we have. And then here, the transform just negative, just so we get a position here. A rotation there. Obviously, this changes throughout time, so I just had to pick a frame where I want to align it. And then the frame that I froze it on is this one here, to use as a transform later. And then also what I did here, I adjusted the flat tank a bit. So I think this was set to 7 before, if I'm not mistaken. So you can just go ahead and open up the scene and just check that out there if you just want to copy the values or just figure it out for yourself. It's shouldn't really make that big of a difference if it's bigger or smaller or whatever. The only thing that it is that you have to check is some ropes do move a bit further out or away from the original emerging position, just to take that into account. And so you get the main area where it comes through the water, that you cover that with the flat tank area. And then the other thing that I changed here is obviously the animation of the stretch. So if you look here, the beginning, if we disable that, we get our banding again. And so just stretch that there, animated it, and then it stops, goes down to 0, since it's not moving that fast here in this area. And then towards the end, starts to pick up again, just to get rid of that banding here. If I disable that there, you can see the effect that it's having. And this is a very subtle effect that it will have. I I mean, not subtle, but the effect itself, so the whitewater, is going to be a subtle effect overall, but this will make a huge difference if we have a banding or not, so otherwise that would just pop out. And I think the rest was all the same, didn't really change anything there. Pretty much standard thing that we had set up with the rope 2, so the same thing. Now for the second rope, here under settings, I changed this to frame 20, so it's the same that we have for the pillar. The transform here, it was set to 18, just so we get that centered. Let me see which frame that would be. Yeah, so it's probably this rope here. And then the frame that I took here is 1080 as a freeze frame. And then from there, also adapt the flat tank a bit. Could make it a bit smaller because the rope is also smaller, so we can reduce that area. And then what else did I change? Oh yeah, of course here, the stretching again, same thing as with all the others. Also just went through, animated it, checked if it needs it or if it doesn't. So like you go through it and then check, does it need it? No. Then I can animate down to 0, go into a frame where it starts to appear again. So for example here, if I check, there's this banding again, and then I just animate that until we get a value where this looks nice again. Last, the fourth rope, rope number 3. Settings, this one is the one that shoots out quite late. So just went higher here in the start frame, which is the same that we have for the pillar. Transform here, 56.1, which sets this rope here straight. And then the burst frame is also a bit later here at 150. And then also the flat tank, I had to make this one a bit bigger because this is one of the longest ropes that we have. Just change that there. I think I made it a bit smaller because it's not moving that much sideways, but it is quite large. And yeah, then the animation of the whitewater again, same thing with the stretching. So just go through that. And then should be good to go. So if you're lazy, you can just go ahead, open up the scene and copy this. I mean, if you're having the exact same simulation, then this should work for you as well. If you're animating, or if you don't have ropes in your simulation, then probably could have skipped this entire section, although there's some interesting stuff that we do cover. For example, the stretching here, post fixes like that. And so this covers the entire simulation section. So what do we have here? Sim rope. I think this was an empty container we created in the beginning, so we can get rid of that one. All right, so we're done simulating everything. We've simulated our pillars, our main ship, and the ropes. So what we're going to be doing next is creating the environment. So just quickly setting that up. I'm not going to go over the entire process of how to create basically an environment, but I will go over the steps that it takes to get there. So getting a terrain, which I set up in Houdini, and then I'll provide you with that file, so you definitely can use that. So don't you have to think there, oh, I don't have the geometry, now I can't render it as nice. So I definitely want to be sure that you can replicate the exact same thing here. That's why I will provide that as well. But definitely go ahead and create your own terrain. Just make it look a bit different, more interesting. I mean, you could place this wherever you want, in a desert or whatever, anything that inspires you, that you think looks nice, or some weird, strange planet on some other solar system where you have, I don't know, some strange mountain shapes or maybe a cityscape in the background. It doesn't have to be nature. For what we're doing, we went over this in the beginning in the reference part. We're going to have this sitting on a calm lake somewhere in the woods between some mountains. And so quickly go over that. And then after we set up our environment, that also includes the lake. So the setup of the ocean spectrum. So we're going to quickly jump over that. And then after that, we're going to go into the shading part of our whitewater and also of our regular flip water, and also the smoke and mist part, and to conclude basically the rendering section there. So see you in the next section. Let's save our scene here, maybe do a new version, and then we'll continue in the environment part.